Hi folks, welcome to today's self-service analysis straight from MotherDuck. My name is Tom. I am the CEO of Concept to Cloud and we build the Saiku analytics platform. Thank you very much again for joining us. Hopefully today is an insightful day. We're going to look at what you Saiku Cloud 1.0 and why you'd want to use it with the MotherDuck analytics platform. So I'm going to dive straight in and just sort of like look at the highlights of why you might use Saiku alongside MotherDuck, because most teams, they don't have a data problem. We exist in the 21st century. I mean, there is a huge amount of data all over the place, but what teams do struggle with is data access. How do they make that data available to end users, to different platforms? How do you know that across your organization you're counting the same things in the same way? And so that's what a semantic layer like Saiku is supposed to provide in terms of making sure that across an organization everybody has access to the data is secure, but also it says the same things to different people where it should, obviously match up. So if you don't know anything about MotherDuck, they are an analytics platform based on DuckDB, obviously written by the guys who built DuckDB, and it's a SaaS platform that you can upload and ingest huge amounts of data. Now, we haven't got a massive data set today, but we'll show you something that scales a little bit. A little bit about Saiku. It's not a standard BI tool, it's a semantic model tool that sits on top of your engine. Now, MotherDuck is one example, it could be other things. But you build it once and you can use it everywhere. Saiku allows you to create these schemas, create these models using an inbuilt inference engine that can generate schemas on your behalf. It will allow you to publish those schemas, test them, and then tweak them, again, automatically or manually after you've created them to allow for, easy model creation. As I said earlier, you want to define it once and then agree on those metrics everywhere. You do that with a model inside of Saiku Cloud. Every role has its own view, and of course, across an organization, you may want people to see data and not see different bits of data, but you don't want to rebuild the model or rebuild connections for specific teams. And so role level security and row level security, a bit of a mouthful, is there to allow for that type of thing to happen. The other thing as well is obviously we've built Saiku for the 21st century with AI being at the forefront, and so this allows us to create APIs, MCP servers, and other interactive portals to really drive insight and inference from the data for your team. So like I said, the whole team gets the same models or can have the same models, but they are organized differently, but they allow for organizational completeness from a data picture perspective. And so the same governed model answers the whole organization's questions, and you don't have individual teams doing their own thing. So I want to have a look at what this looks like on some real data. So like I said, we're going to do this with MotherDuck. We're going to connect to a MotherDuck database. We're going to allow the model to create itself. That takes a little while, so I will show you how that starts and then leave it to do its thing. We're going to explore and drill through the data, and then we're going to have a look at how we share that data with the team. Okie dokie. I will, first of all, flip to this tab. So this, for anyone who's never seen MotherDuck before, this is the MotherDuck platform. It's reasonably bare bones, but that's obviously what you want from a database. So I've logged in, I'm in my Spicule data environment, and inside of here I have a number of different notebooks. I'm not going to get too in depth, but for anyone who comes from a data science background, you'll know exactly what a notebook is. For anyone who doesn't, it's a place where you can obviously run scripts, SQL scripts in this case, to be able to load up data into your MotherDuck environment. They can do a whole host of other stuff as well. They can do all sorts of analytics and other interesting things. But for our point of view, this takes what I know as the GDELT data set, which is global events, and then deploys it into the blue sky, the MotherDuck environment. Inside of here, we've created a star schema, but it starts slightly differently. So if we look at GDELT events, this table down here, if I, see if I can make this bigger, there we go. You can see it's got 38.4 million rows. It's quite a wide table. It's got all sorts of bits and pieces in it. And the nice thing about MotherDuck is that, you know, you really get to sort of dip into how some of this is structured. You can have a quick look at how some of the data is stuck together if you're not familiar with the data. You can do all sorts like show distributions, all that type of thing. So if I click on this one, you can have a quick look at the inference of the data without having to actually write anything. You know, I haven't written any code. My data is just sat there inside of the database. The node is spinning up. We'll come back to that one in a sec. But then on top of that, we've then built a number of different two different fact tables, one for events, one for mentions. There you go. You can see the inference load up. That's a really nice view. I like that. Yeah, you can see that we've built a number of different fact tables. This is a star schema. So we've got mentions and events, and then we've got a number of different specific tables that are there for us to be able to generate metrics off of them, the dimensions. And so here we've got date, we've got country, we've got actor type, and so on and so on and so on. They follow a reasonably standard naming convention, which is like fact underscore, F underscore, and then dim underscore, D underscore, you know, which sort of helps guide the inference as well when we get into Saiku. So that's not a bad thing. But here you can see that, you know, we have a date table with 1,000 rows in it. And then inside of that, we have a number of different like labels, fields that allow us to do sort of date visualization. And, you know, the others are all very similar. So then I am going to flip from there and attempt to show you Saiku Cloud. Okay. So if I click back to the start, what we wanted to build with Saiku Cloud is an environment that allows people to host the analytics and not have to host their own, because Saiku is an open source piece of software, the analysis tool, but obviously the cost of ownership and the cost of running that thing is not free. Saiku Cloud has a number of extensions, enhancements, and improvements in it that allow you to be able to get easy access to your data without having to worry about how to be able to host it, support it, upgrade it, all those types of things. So I'm logged in here as my test corp user, as you can see here. And then we're going to have a little look at how you would get some data into Saiku Cloud. So if I click on data sources, you can see that I've created a number of like different test data sources here. Some are literally called test. But we're going to look at various different ways of being able to connect to this. Down the bottom here is the actual connection that I ironically didn't label, but that's the connection we're going to look at. So once again, if I make this a bit bigger, if I hit design cube, now what that is going to do is this is going to use our AI inference engine to go and design the cube. It's going to look at the tables that you have available to you. It's going to look at the fields inside the table in terms of, you know, are they strings, are they integers, are they date fields, like how is your data structured? And then it's going to go and attempt to design a cube that will then sit over the top of that data. Now, as with all of these things, it depends on what you're trying to build. It depends on, like, you know, the angle that you want to take with your data as to what you're going to get out the far side. This is sort of the onboarding flow in the way that we like to be able to show people, because it allows people to get set up, you know, quickly and easily. You know, and so inside of here, as it goes through, having a look at the data, it's not sending your data to an AI service. It's literally sending information about the tables, the table structure, and the content of that table itself without sending any actual chunks of data. So as that was, just going back to why we would use MotherDuck, of course, like I explained earlier, MotherDuck is amazing at scalable data. You can do a whole bunch of stuff on your laptop. You do not need to necessarily spin up MotherDuck, but at the same time, people want to be able to share data, disseminate data, and have access to data at a high rate of knots. And so by allowing them to, leverage what we're trying to do here with with Saiku and with the Cube Designer, this really allows them to get access to the different things. Now, if I go and have a look, because that one was still in the process of being designed, I'm going to look at Food Mart just to show you a similar one. But you can see here, effectively what you're going to end up with is an XML document or a YAML document that explains what the layout is supposed to look like. So you've got a physical schema that explains some of the tables. You've then got the actual tables themselves, and so on and so on. If we click on, if we go back up and then we have a look at another one, they're all very similar. And then I'm going to have a look at this GDelt one that we have here. So the GDelt one, as you can see, uses fact mentions and fact events. Let's see if I can make it bigger again. Fact mentions, fact events that we were talking about earlier. The various dimensions that sit in there, and then the dimensions and the spec of the dimensions themselves. So they have a key, they have a nice looking name so that you don't end up just with like random numbers, so on and so on. They specify how your analysis is going to look, and you can change this over time. Like, this is not something that is set in stone. You can come in here if you're comfortable editing XML. You can go in, you can edit the XML. For those of you who are new to anything to do with Mondrian and anything else that we do on the platform, the docs site is a great place to start. It goes through everything from a Saiku perspective, but also how to deal with the OLAP engine that sits underneath. Our OLAP engine is Mondrian. It's been around for a while. We're now stewarding it through the version 4 era. We've added more functionality and other like fun bits in terms of 21st century tooling, observability, all that type of thing. So if you're interested, come into the docs. You'll find inside of the docs there are plenty of examples, both in YAML form and XML form, depending on which format you want to write the schema in. You cannot write them in both. I mean, you can write them individually in both, but you can't write them, you can't mix them. But yeah, inside of here are all the examples as to how to like write the schema you want to be able to write, and then to be able to deploy it to your service. We are working on improving, I've gone the wrong way, there we go. Working on improving the schema designer. But again, you can come in here, you can author a cube. I can say I want to be able to look at something specific. I can give it some details. It'll go and draft my cube. So we've then created a cube that then sits on top of the GDelt data from MotherDuck. If we wanted to do one for FoodMart, I could do something like, I would like to look at the sales performance against products in the well, that should do it. Let's do that one, and then yeah, let's try that. So live demos, there you go. There's always the chances this won't work, but I haven't checked this database connection in a while. But the idea, of course, being that this will again go off to MotherDuck. It will look at the FoodMart schema, the way that works, analyze the connections between the different tables, because this, of course, is a star schema, very much similar to the one we've just built. And then it's going to return a suggestion to us as to how we're going to use it. So whilst that works, I'm going to open another tab. Still going. Inside of here, you can see the different cubes that we have available to our system. Assuming that they are connected and working, you'll see an active notification next to them. You can come in here, you can clear the cache. This allows for individual cube cache. It's not a global cache like anyone who's used Saiku before will know. Here we go. So all for a cube. This is like obviously the screen that we're working on improving in our 1.1 release. But at the moment, you get access to the different levels, the attributes that go with it. So if I look at time, you've got year, quarter, month, day, all inferred by the platform itself. As a diagram, you can see the fact it's joining to various different extension fields. And then if I wanted to actually go and validate it, I can click preview. That's going to show me the source. Obviously, the source is reasonably technical. So then I can show the sample data. So this is the table that it's read from. If I wanted to then try a query, I can come in here. It will run a little sample query. If the cube that it's generated is valid, that query will return some data. Ta-da! So this gives you a good indication that the query that you're trying to, the cube that you're trying to build, like functions in a way that you want it to work. And then I can be like demo 09 06, save it. And then if I go to my cubes, I can see that it's listed the cube. It currently says none. That's whilst it's spinning up a connection and trying to connect to a database. Anyway. I will go back to the analyze screen. Oh, here you go. You can see it's active. You've got one cube. You've got 11 measures and 13 dimensions. That is what the inference layer brings to Saiku from a cube design process. If I then go and have a look at schema 4, because this is the one that's got the interesting stuff in, we're going to come in and have a look at Saiku from an analysis perspective. So again, let me make the screen a bit bigger. Inside of Saiku, we've created this schema that has this GDEL data. So this is connected to MotherDuck. And you can see here we've done an event count. And so it's got 16 million events from 2026, 21 million events from 2020, 22 million events from 2025. And it obviously drops off as you go back. And weirdly, there's some strange events from 2015, 2016. But you might want to say, okay, well, I want to know how that works against, the mentions. So if I bring in mentions, you can see that then there's 102 million mentions. So there's a reasonable amount of data kicking around inside this MotherDuck database. And all I've done is chuck some couple of measures on and a sort of year level definition. So if I was then interested in how that splits down by month, if I go and put month onto rows, you can see now, just doing some high level analysis, that the distribution in 2025, for example, there was far more at the back end of the year than there was at the start of the year. That's probably down to data collection, but you can sort of see the difference in June of 2026, where we're still collecting data. There's obviously far less, but the rest of it's reasonably standard over a period of time. If I then wanted to plot that on a chart, I can push the chart button. And then if I wanted to be able to manipulate what that chart looked like, because you want dual axis or whatever, I can say, okay, I would like to have my mentions on the right, my event on the left, hit OK. Now you can see that we've got dual axis going along. There's all sorts of different charts in here that depend on what type of data that you're trying to plot make more sense than others. And if you go back into here, you can do stuff like trend lines, reference lines, formatting, all sorts of bits and pieces inside the chart editor to make the analysis more useful for your end users. Again, all this running live over the MotherDuck data. The nice thing is with the way that Mondrian works and OLAP works is once you run the query once, if it hits the cache again, it won't go and hit your database. So it's going to reduce your cost from an operations perspective as well, because when it's running, it's not it's not hitting the database all the time. It's going to use the cache as much as humanly possible. Because it's OLAP and crosstab, I will then take a dimension. So if I wanted to then pivot that by Goldstein, you can see that we've bucketed up the Goldstein here so that you sort of get an understanding as to what the conflict looks like. And so was the data that was coming in, in these events, if I take out mentions, for example, to make it a little bit easier to see, was the event neutral? Was it a cooperative event? Was it a conflict? And so you can see over a period of time, like how that plays out in terms of distribution across there. And again, if I wanted to go and chart it, I've got it in a bar chart here. But then if I wanted to be able to see something that made, was a little bit different, I could do stack bar and to still get back to those totals. But then also understand the distribution over that period of time. There are a number of different ways that you would be able to deal with that. And then if I wanted to save it, I could come up and hit the save button. I can select my home folder. I can select save. I can save that and come back time after time and just see the same data on repeat. Now, of course, as I mentioned, there's a number of different ways to be able to interact with the data. Another one is the dashboards. And so if I open up the dashboard here, what we have here is our GDelts event monitor that I built earlier just to sort of show how this would work. Ooh, I kind of zoomed in on the chart. But if I come in here, you can see 38 million events, 174 million articles, 40 million sources, average tone, negative, average Goldstein, slightly positive. So there's slightly more positive, non-conflict events going on, but the average tone, when measured, is very negative. So that's currently the world that we live in over the last couple of years, basically. And again, you can see here that we've got monthly trends, we've got geography, so the chart split out. So most of these events come from the US, the UK, and then obviously it tails off as you go through it. And then as we go down, we've got the event mix, and so how that is dealt with across the different types. So you can see that, there's a lot of consultancy, public statements, but then, a reasonable amount of aid, diplomatic cooperation, and so on and so on. So this is determined by GDelt itself, and MotherDuck goes and then offers that up. Then we've got an intensity heat map, and so you can see there's a lot of neutral stuff going on that is cooperative in nature, but then if I look slightly left, slightly right, it sort of bleeds over into positive and negative. And then if you look up in the conflicts, obviously conflicts, as you would sort of imagine, are very negative. So this type of heat map is useful for this type of plots. Just gives you an idea as to how things work over time. And as we come down, we've got the amount of mentions and where they come from. So iHeart gets scraped a lot. The yahoo.com site, 2 million mentions. And then inside of amplification, again, so how long does it take for it to become amplified by something online? And so here you can see that consultancy, coercion, what else? Again, diplomatic cooperation. There's a bunch of very obvious bumps there. Public statements. You'd expect someone to make a public statement. It gets amplified online. This is the data that you're getting out of GDelt, but this is all being served inside of Saiku on a standard cube that anyone inside the organization, if this data was of interest to you, could then go and use. You can use present mode to make this full screen, which is always cool. I should probably have done that earlier. But you get the idea. You drop into Saiku, you can go and do the analysis, you can figure out what's important to you, and then you can visualize that on the screen. The cube that I just created, let's drop into that. So you can see here that it's created sales performance, a sales cube, and then you can see that this is using the FoodMart dataset to be able to create this cube. So I've got year. If I then wanted to be able to look at this against store state, for example, let me go and stick that one up there. Obviously, you've got a mix of Mexican and American there. So, okay, I want to be able to stick store country in. And I will once again move it up there. So you've got Canada as well. But you get the idea. So you can start to be able to slice and dice by different things, and then you can go back, you can manipulate your Saiku environment to be able to sort of tune the cube to what you want it to be. I will go and select one more, and then we're going to use this Ask the AI functionality on the toolbar because, of course, people want to be able to interact with their data in different ways. So if I drop into here and then I say, show me sales by country, this is very much still in beta testing. We're working on this. So if people want to test this and give us feedback for improvement, happy to take it. But there you go. So you can see, show me sales by country. It'll tell you what MDX it wrote. That's the query language that underpins Saiku itself. And then it's going to show you on the screen. And then go, okay, can I cross tab that with customer countries? Oop. It'll go away and it'll attempt to write another MDX query. It wants from the US. Okay. Add state events to the. See how far we can get. But you sort of get the idea. Obviously, there we go. So we can start to split things out. We can ask inference questions. We can get him to do a lot more complex stuff by understanding the nature of the schema and the queries that you want to be able to write. And again, you can drop into this. You can then go and visualize stuff on the screen. It's a nice way of being able to deal with trying to uncover trends in analysis inside of Saiku in a way that could be automated. You can do a bunch of different stuff. Now, obviously, talking about automation, we spoke about AI back at the start. And so I want to just quickly drop into Claude desktops. And if I click that button, okay, let's see if we can do this. This is connected to the staging environment, just so you're aware before full disclosure. Okay, show me analysis of So what we've done with Saiku is we've written an MCP connector and an AI API as well. So depending on how you want to interact with it, there's a couple of different ways. This is using the MCP connector to go and connect to Saiku. It's going to use the AI API to then be able to create a query that's very much guided in the way that it works, rather than having Saiku, rather than having Claude guess numbers, he's going to go and ask for information from the API. He's going to come back. He's going to then infer some of the information from it. He can then, because we guide him with the API responses, he can then ask follow-up questions and also deal with data provenance and data lineage over time. By leveraging this API. And so under the hood, same models, same connections, but you can see him here. He's off, working through the different aspects of the store sales. And here we go. So we get, depending on how your Claude is set up or what you ask for, he's gone back and tried to understand from the data what he can return. So here you've got yearly income band, all that type of stuff. Inside a Claude desktop these days, of course, you can get him to, create graphs, charts, plot things. But you can obviously leverage this not in a chatbot, but in various other platforms that are also AI driven. So, if you need standardized data inside of an AI-driven environment or a business environment that is not someone clicking, dragging, moving stuff around, Saiku has always been sort of a REST API, and now it has this AI API to really drive that insight and knowledge in a way that doesn't have, Claude guessing across a number of different tables, because he can only do the stuff that the schema allows him to do. And again, same with any other user. This is logged in using OAuth, and so when I do log in, all I can do is the same stuff that I can do if it was me as a user as well. So going back just finally to Saiku Cloud, this is my starter level. So this is what you get from a start level. As you go up through the levels, there is more connectivity, there is more like audit and enterprise features, but this is a great way to get you going. You can come in, create a schema, do your work, analyze it inside of Saiku, and then make sure that you can get access or give access to everybody in your team. If I come in here, I can invite other people. They will get an invite to Saiku Cloud. They can come in, they can do their stuff. And so that's Saiku Cloud, and that's MotherDuck. And so I hope that this has been useful. We're just going to wrap up like briefly. You know, with Saiku, what you end up with is one. Let me flip to the right screen so we can all share this. There we go. So with Saiku, you end up with one self-serve subscription, a model that can build itself. You've got self-service for the whole team and answers in minutes. You know, compared to what's gone before. And, you know, obviously the idea with Saiku is you can both provide interactive analytics, you can connect it to Excel so people can still use pivot tables underpinned by a giant database in MotherDuck, or pick your own flavor of something else. And so this really allows us to be able to drive, you know, high-level analytics that are consistent across an entire organization. I mentioned earlier, the idea with the OLAP engine is it leverages the cache. And so either because the queries are slow, because they are intensive in terms of compute, or because of the costs that you don't want to incur if people are looking at the same dashboard on repeat every day, you know, what we end up doing here is caching the results so that when you go back, it's snappy, it's quick, it works straight away. But at the same time, what that allows you to do is then also reduce your like cloud bills, your cloud costs, because you're not then paying for the compute when people are just looking at the same stuff. So how does this work in terms of pricing? Saiku Cloud starter from $99 a month. Bring your own cloud or 5 gigabytes of file upload, shared compute pool, email support from us here at Concept to Cloud. For $500 or $499 a month, it's always on, it's governed, you've got SSO features, you've got more audit logs and PII redaction that goes on with it. And for $1,500 a month, you know, we do more with scale, more HA things, depending on what you need as an organization. There is also, if you want to install on-prem an enterprise version of this that we can ship to you, we will give you a named developer, a named support lead, who will be able to make sure that everything gets installed for you. You can install this on-premise and we will be there to support you all the way. So there we go. I hope everyone has found this insightful and useful. I hope that you will join me again soon. Keep an eye out for the Saiku schools, because we are starting an education course as to how to get the most out of your data using Saiku. And that is it. Thank you very much for watching.